Hello guys, this is chapter number 10, straight lines. Today I am going to discuss the even number of examples from the miscellaneous exercise. Let's get started. So here is the question number 2. To find the values of theta and p if the equation x cos theta plus y sin theta is equal to p is the normal form of the line root 3x plus y plus 2 equal to 0. So we have the equation root 3x plus y plus 2 equal to 0. If I compare this line into ax plus by plus c equal to 0, then I'll get a is equal to root 3 and b is equal to 1. Right? I'm going to divide this line by under root a square plus b square. So under root a square plus b square gives me root 3 square is 3 and 1 square is 1, that is equal to 2. So I'm going to divide the above line by this 2. So I'll get root 3 by 2x plus 1 by 2y plus 2 by 2 1 is equal to 0. Now I have to compare this line with this x cos theta plus y sin theta is equal to p. So therefore I'll write root 3 by 2x plus 1 by 2y is equal to minus 1. I'm going to take this p positive, so I multiply this whole equation by minus 1 and then I'll get root 3 by 2 negative x minus 1 by 2y is equal to plus 1. Compare this equation with this, I'll get p equal to 1. So now onwards, comparing with this line, I'll get cos theta is equal to minus root 3 by 2 and sin theta is equal to minus 1 by 2. Here both trigonometric terms are negative. So according to this all STC, both are negative in third quadrant, right? So I can say that theta lies in third quadrant. Theta lies in third quadrant, right? So therefore I can write theta is equal to pi plus, for this value theta will be pi by 6. So final answer is theta is equal to 7 pi by 6. Hence the answer. Let's get to the another example. Now question number 4. What it says, what are the points on y-axis whose distance from this line is 4 unit? I have the line x by 3 plus y by 4 is equal to 1. If I take LCM, I'll get 4x plus 3y whole by 12 is equal to 1, and cross multiplication will give me minus 12. So my equation ax plus by plus c equation will be 4x plus 3y minus 12 equal to 0. Now I need to find the point which is on y-axis. So point on y-axis will be 0 comma h. So let me write that. Let 0 comma h be the point on the y-axis, be the point on y-axis whose distance is 4 unit from this line, from the above line. Now perpendicular distance from any line to the point is, it is given by d is equal to ax1 plus by1 plus c modulus upon under root a square plus b square. From this line I can say that I have a equal to 4, b equal to 3 and c is equal to minus 12. I am getting these values from this equation of line. Now d equal to, I have 4, so I'll get 4 is equal to point x1 and y1 is this point. point x1 y1 is this 0 comma h, correct? So ax1, so a into 0 is 0 plus b into y1, so 3 comma 3 into h plus c, that is minus 12 upon under root a square plus b square. A square is 4 square, that is 16, plus b square, that is 9. I'm writing these values from this thing. Right? Simplifying this term, I'll get under root 16 plus 9, this is 25, and square root of 25 is 5. 5 4s are 20, so I'll get 20 is equal to 3h minus 2 in modulus. Right? Let's solve this equation. So finally we have 3h minus 12 is equal to 20. Now whenever I remove the modulus, we get positive and negative on opposite side. So I have to write plus or minus 20. Now 3h minus 12 is equal to, 3h minus 12 is equal to plus 20, or I can say 3h minus 12 is equal to plus 20, right? So it is negative 20. So first I'll solve this one. 20 plus 12, 12 plus 20. So 3h is equal to, I'll get 32. Therefore h is equal to 32 by 3. Also this equation 3h is equal to minus 20 plus 12. So 3h will be minus 8. So h is equal to minus 8 by 3. I'm getting two different values of h. So my answer is the required point on y-axis. The required point on y-axis, which I assume 0 comma h, is, it can be 0 comma 32 by 3 or 0 comma minus 8 by 3. That's it. Okay, so let's go to the another example. As I said, we are going to discuss even number of questions. So let's get the example number. Question number 6. Find the equation of line parallel to y-axis and drawn the point of intersection of the lines x minus 7y plus 5 equal to 0 and 3x plus y equal to 0. So we have two different lines, say L1 and L2. Let me say L1 is equal to x minus 7y plus 5 equal to 0 and L2 say 3x plus y equal to 0. Now we know the equation of line passing through the intersection of these two lines is denoted by L1 plus lambda times L2 is equal to 0. According to this formula, let me write x minus 7y plus 5 plus lambda times another line, that is 3x plus 5 equal to 0. If I take x and y common, if I take x and y common, you can observe the things like, let me highlight with this color, with this. Here it is x, here it is x, and for yellow color, that it is y, and there is no y term. So I can write 1 plus 3 lambda into x common, plus here it will be minus 7, and here it is lambda, only 1 lambda I can say. I think I made a mistake. Here it is not 5, but it is y. Correct? So it is y. So minus 7, and from here L1 lambda into y plus, now 5 is alone, plus 5 equal to 0. Right? Now this whole line is parallel to y-axis. This line is parallel to y-axis. If a line is parallel to y-axis, so we can say that coefficient of y is equal to 0. So I can write the thing as -7 plus lambda equal to 0. So we will get lambda is equal to 7. So lambda was the unknown quantity in this equation number 1, right? And now it is known. So substitute this lambda in equation from equation number 2. Let me say this is equation number 2. What we get? Y equal to 0, and from lambda's value 7, we get 1 plus 21 into x plus y term is 0, so plus 5 equal to 0. The value of x is equal to, you can say, minus 5 by 22, or else you can write that 22x plus 5 equal to 0. That is the required equation of line. Okay, so now let's go to the another question. Find the area of the triangle formed by these three lines. So this line x minus y minus x equal to 0 is actually, if you draw the on it on a graph paper or in a Cartesian plane, it is y equal to x. It represents this line. Next, x plus y is equal to 0 represents this line. Okay, I'll extend it to another quadrant. So these two lines are there. This is x plus y equal to 0, means x equal to minus y. This is x minus y equal to 0. And third line, x minus k equal to 0, means x equal to k. If this is k, if this value is k, I can draw a straight line like this, x minus k equal to 0. Now I am interested into this intersection points, these three intersection points. Okay, I'm interested into these three intersection points, and this is my triangle. We have to find the area of this triangle, right? So let us denote this line y minus x equal to 0, x plus y equal to 0, and third line is x minus k equal to 0, right? So say this is 1, say this is 2, and say this is 3. Intersection of two lines, 1 and 2. So if I eliminate x, we'll get 2y equal to 0. So therefore y equal to 0. And if I put y equal to 0 in equation 1, we will get x equal to 0. So intersection point of 1 and 2 gives you 0, 0. Another two lines from line 2 and line 3. If I eliminate x, we get, uh, y plus k equal to 0. So y equal to minus k, and whenever I put y equal to minus k, I'll get x equal to k, right? Also, moving to another two lines from lines 3 and line 1. If I eliminate again x, we'll get y minus k equal to 0. So we'll get y equal to k, and whenever I put y equal to k in line 1, I'll get x equal to k. So we have three different points. Say 0, 0. Another one is kk, and another one is k minus k. Again, I am repeating. So we have three distinct points which represents a triangle: 0, 0, k comma minus k, sorry, k comma plus k, and k comma minus k. If I write this as x1 y1, x2 y2, x3 y3, then the area of triangle, then the area of triangle is equal to that formula 1 by 2 modulus x1 y2 minus y3 plus x2 y3 minus y1 plus x3 y1 minus y2. So according to this formula, if I substitute the value, I'll get final answer as, okay, let me write 0. This is k minus k, sorry, k plus k plus x2 is k, y3 is minus k minus y1, y1 is 0 plus x3, x3 is again k, y1, y1 is 0 and y2 is k. Sorry, this is minus and modulus. When I solve this term, we'll get minus k square minus k square. Forwarding it, will get minus 2k square. And to cancel with modulus, and whenever I remove modulus, negative will be positive, so we'll get k square square unit. And this is the area of the triangle represented by those three lines. Okay, let's go to the another one. Question number 10. If three lines whose equations are y is equal to m1x plus c1, y is equal to m2x plus c2, and y is equal to m3x plus c3 and are concurrent, then show that this expression. We have three lines. Say y is equal to m1x plus c1, y is equal to m2x plus c2, and y is equal to m3x plus c3. This example has just mathematical calculation, right? So let me tell you this thing. If the lines are concurrent, that means they passing through the one single point. It will be the case like this. It will be the case like this. This is the point of intersection, and three lines are like this way, right? Okay. So let us say this is equation 1, equation number 2, and equation number 3. Let us find out the intersection point of line 1 and 2. So for that, what I will do, intersection point of 1 and 2. So what I will do, y is equal to m1x plus c1, y is equal to m2x plus c2. I'll eliminate y, so I'll put minus over here, minus over here. Next, when I'll solve this equation, I'll get m1 minus m2 x plus c1 minus c2 is equal to y minus y is equal to 0. If I simplify in a simple way, if I simplify this term expression, I'll get x is equal to minus times c1 minus c2 upon m1 minus m2. Correct? Now, whenever I have x coordinate, I'll put this value in any of the equation. Let us say in equation number 1, I'll get another coordinate, say y. So let's go to the blank page. Now, the value of x was minus times c1 minus c2 upon m1 minus m2, right? The equation of first line was y is equal to m1x plus c1. So m1 times this minus, okay, let me write it down again, equal to this minus, I am putting this at here, and now c1 minus c2 upon m1 minus m2 into x, sorry, this was the value of x, so no need to write x again, plus c1. Now just take LCM, and now just take LCM and some other calculations. Minus m1 c1 minus minus plus m2 c2, m2 c2 plus c1 m1 minus m2 c2, right, whole upon m1 minus m2. So y is equal to m1 c2 minus m2 c1 whole upon m1 minus m2. So now we have this intersection point, right? Also the line y is equal to m3, another third line, m3x plus c3, this line passing through the same point. So this coordinates minus times c1 minus c2 upon m1 minus m2, comma m1 minus m2, comma mc2 minus m2 c1 upon m1 minus m2 will pass from this line. So this point will satisfy this point, this, sorry, this, oh, just a minute. Now this point a comma b will satisfy where is my pen? This point will satisfy this equation. So put the values of x and y, and you will get some expression which you want to prove, right? So I'm not going to explain it anymore, and going to the another example. Let's discuss question number 12. Find the equation of line passing through the point of intersection of these two lines, and thus has equal intercept on the axis. Again, it is the similar question like the previous one. Equation of line passing through two lines is represented by L1 plus lambda times L2 equal to 0. According to this point, let me write 4x plus 7y minus 3 plus lambda times 2x minus 3y plus 1 equal to 0. Again, taking x and y common, I'm not going to spare much on the time. I'll get 4 plus 2 lambda times x plus I'll get 7 here and minus 3 lambda on the another bracket, minus 3 lambda into y. From here I'll get minus 3, and from here I'll get plus lambda equal to 0. Now let us write this equation, this expression as 4 plus 2 lambda times ax plus, say this is b, y is equal to, I'm going to write it 3 minus lambda, right? Now equation of line which takes x and y intersect on the axis is given by, x by a plus y by b equal to 1. I'm going to represent this line on this expression. So what I'm going to do is I'll divide this line by this expression 3 minus lambda. So let me do that. So we get 4 plus 2 lambda upon 3 minus lambda times x plus 7 minus 3 lambda upon 3 minus lambda times y is equal to 1. Okay, to compare with this, we need to write x upon, now make sure that you will not do any type of mistake. This upon 4 plus 2 lambda plus y upon 3 minus lambda upon 7 minus 3 lambda equal to 1. So now compare with this above line with this line and you will get some a and b. I mean x-intercept and y-intercept. So x-intercept is equal to x-intercept is equal to, I can't go to the previous slide, so I am directly writing 3 minus lambda upon 4 plus 2 lambda, and y-intercept is equal to 3 minus lambda upon 7 minus 3 lambda. Now the question was that these intercepts are equal, so I can write from the question that 3 minus lambda upon 4 plus 2 lambda is equal to 3 minus lambda upon 7 minus 3 lambda. Numerator can cancelled from both sides, and therefore I can write 7 minus 3 lambda is equal to 4 plus 2 lambda. If I solve this equation, this expression, I will get lambda is equal to 3 by 5, which was the unknown. So on the from the main equation, that is and I put the value of lambda, I'll get 4 plus 6 by 5. As I cannot go to the previous slide, I'm going to write it directly. 7 minus 9 by 5 y is equal to, if you remember, it was 3 minus lambda, 3 minus 3 by 5. If I take LCM and solve this expression, we'll get 26 by 5x plus 26 by 5y is equal to 12 by 5. Performing one more step, we'll get 13x plus 13y is equal to 6, which is required equation of line. That's it. Thank you very much.